A Chinese probe returns to Earth with samples from the far side of the Moon. The first samples taken from the far side of the Moon are heading to Earth. The China National Space Administration announced that the lander of the zci10 mission, which landed in the Apollo crater in the South Pole Aitken Impact Basin on June 2, has completed sampling and is returning home. The probe with valuable cargo is scheduled to land on Earth at the end of June. On the night from Saturday to Sunday, Polish time, the zci10 probe landed on the far side of the Moon with the mission of collecting samples and sending them to Earth. According to the China National Space Administration, CNSA, the lander completed sampling in 2 days. He collected material from the surface of the silver globe. He also drilled into its soil and took samples from beneath the surface. The sample collection process went smoothly, admitted Chun-Lei Li, Deputy Chief Mission Designer at the National Astronomical Observatory in Beijing. According to the plan, the material collected from the Moon will weigh approximately 2 kilograms. After loading and securing the samples, the return vehicle departed from the Moon on Tuesday morning, using the lander as a launch pad. They will reach the designated orbit after 6 minutes, CNSA reported. These are the first samples taken from the far side of the Moon to reach Earth. A Chinese probe landed in the South Pole Aitken Impact Basin. It is the largest known impact structure in the entire solar system and the oldest on the Moon. Because of this, researchers believe the samples will consist mainly of basalts, a dark volcanic rock. Similar material had previously been brought to Earth for analysis from the visible side of the Moon. These rocks are estimated to be around 2.4 billion years old, much younger than the South Pole Aitken Basin itself. The collected regolith should also contain fragments of older rocks, said geologist Alfred McEwen from the University of Arizona in Tucson. Scientists hope the samples will help pinpoint the age of the huge impact structure and deepen our understanding of the early history of Earth and other planets. Scientists highly value the scientific value of the samples, provided they manage to reach Earth without any obstacles. These are the first materials from the far side of the Moon, which is significantly different from the visible side. Determining the age and composition of material from the far side of the Moon is like having a treasure chest full of critical parts of the Moon's history and will likely revolutionize our view of the silver globe, said Jim Head of Brown University in Providence, Rhode Island, USA. Now the return vehicle from the zci10 mission will face one of the most difficult parts of the entire endeavor. The idea is to meet and dock with the orbiter orbiting the Moon, on which the samples are to reach Earth. We have 2 probes orbiting the Moon separately at 5,900 kilometers per hour that need to meet and gently touch each other without colliding with each other, explained Jonathan McDowell of the Harvard-Smithsonian Center for Astrophysics in Cambridge. The return trip to Earth will take about 3 weeks, ending with the re-entry capsule entering the atmosphere and landing on the grassy steppes of Inner Mongolia. The landing is scheduled to take place on June 25. Problems of the Hubble Space Telescope. The Hubble Space Telescope entered emergency mode on May 24 due to ongoing gyroscope problems. For this reason, observations were suspended. NASA announced that the telescope will be reconfigured to work with only one gyroscope. This will reduce the efficiency of the observatory, but will allow it to operate for years to come. The Hubble Space Telescope is one of the most important scientific instruments in astronomy ever created. It was launched into space in 1990 and since then it has been delighting us with its photographs of deep space. During all these years in orbit, the telescope suffered numerous failures. The first problems appeared right after the equipment was launched. researchers noticed that the telescope's resolution was significantly different from the expected one. The problem turned out to be the main mirror, which had an incorrect profile due to errors in the measuring equipment on Earth. Therefore, a service mission was sent in 1993 to correct the defect. There were 5 service missions in total. New tools were installed on the telescope deck and repairs were made. New gyroscopes were also installed, because they were failing almost from the beginning of the mission. During normal operation, the telescope uses 3 gyroscopes to orient itself to the observing target. There are 6 of them in total. In 1999, the 4th gyroscope refused to work. A service mission that took place the same year replaced all the gyroscopes and the onboard computer. All gyroscopes were also replaced during the last service mission in 2009. Gyroscope problems are the bane of telescopes. They are very precise, but also capricious. Gyroscopes keep the telescope stable and allow it to look in the right direction. They are an essential part of the system that determines and controls the direction in which the telescope is looking. The Hubble telescope has 6 gyroscopes on board, but it only needs 3 to function properly. Half of them played a backup role. But over the years in space, the gyroscopes failed again. Until recently, the telescope had 3 working gyroscopes, but one of them increasingly returned erroneous readings, causing the telescope to repeatedly go into emergency mode and suspend science observations. On May 24th, the telescope entered emergency mode again. Although the equipment itself and its scientific instruments are in good condition, observations have been interrupted. At yesterday's, June 4, 2024, press conference, NASA representatives announced that they intend to take a step they have been considering for a long time. The Hubble Space Telescope will operate with only one gyroscope, and the second gyroscope, still operational, will act as a backup. Observations will be suspended until the telescope and ground system are reconfigured. This change will enable the telescope to continue operating for years to come, although operating on one gyroscope will limit the observatory's performance. The NASA team expects to resume science operations by mid-June. The Hubble telescope uses 3 gyroscopes to maximize efficiency, but can make observations with only one gyroscope. NASA first developed this plan more than 20 years ago to extend Hubble's life and enable it to efficiently provide consistent science data using fewer than 3 operating gyroscopes. The telescope already operated with 2 functioning gyroscopes in the years 2005-2009. NASA researchers say that operations performed with 2 gyroscopes are only slightly different from the mode in which the telescope operates with one. Moreover, the operation of Hubble with only one working gyroscope was briefly demonstrated in 2008 and it did not affect the quality of the photos. Although there are some limitations, the observatory will need more time to pivot and focus on its target. It will rely on other sensors to verify its position. There will also not be as much flexibility as to where he can conduct observations at any given time. It will also not be able to track fast-moving objects such as comets or asteroids. NASA engineers estimated that operating on a single gyroscope would reduce the observatory's efficiency by about 12%. They also estimated that there are over 70% chances that the Hubble telescope will have at least one functional gyroscope by 2035. A plastic-eating fungus has been identified. Dutch scientists have identified an aquatic fungus that can decompose plastic waste. They found it on pieces of plastic that make up the Great Pacific Garbage Patch. The fungus Pharyngiodontium album lives with other marine microbes on tiny pieces of plastic trash in the ocean. It was discovered by hydromycologists from the Royal Netherlands Institute for Marine Research, NIOZ, together with colleagues from the University of Utrecht, the Ocean Cleanup Foundation and research institutes in Paris, Copenhagen, and St. Gallen in Switzerland. This fungus is able to decompose polyethylene, PE, a plastic used to produce bags, plastic bottles, and other packaging. It is the most abundant of all plastics that have ended up in the ocean. The description and results of the research were published in the journal Science of the Total Environment. Plastic pollution of the seas and oceans is a serious problem. This applies to all marine environments. Plastic waste has been detected in surface waters, deep seas, bottom sediments, and on beaches, from the Arctic to the tropics. Plastic production worldwide exceeds 400 million tons per year. Unfortunately, a significant part of them ends up in the seas and oceans. Surface currents carry pollutants from near the coasts into the ocean. There, garbage is retained by other currents and accumulates over time. This is how islands of plastic garbage are created. There are several such islands in the world. The Great Pacific Garbage Patch, located between California and Hawaii, is the largest of them. Experts estimate that it may contain up to 80,000 tons of garbage scattered over an area of over 1.5 million square kilometers. Conventional plastics are man-made, often petroleum-derived polymers that are chemically inert and designed to be durable. Efforts to replace the most popular plastics with materials that are more easily degradable have so far been largely unsuccessful. The littering of the seas and oceans is also progressing. Scientists predict that by 2060, both plastic production and the amount of plastic waste in the oceans will triple. However, plastic can also serve as a potential source of carbon and energy for microbes. The problem is that the ability of marine microbes, especially fungi, to degrade plastic is little understood. The fungus Pharyngiodontium album can help solve the problem of plastic waste in seas and oceans. It was isolated by NIOZ researchers from floating plastic pieces that make up the Great Pacific Garbage Patch, specifically from biofilms covering floating plastic fragments. Analysis of the fungus revealed its ability to degrade polyethylene in the marine environment. So far, only 4 aquatic plastic degrading fungi have been identified, but researchers expect many more similar fungi to live in deeper parts of the ocean. However, there is a catch to this discovery. Pharyngiodontium album can degrade polyethylene, provided it has first been exposed to UV radiation from sunlight. Marine biologist and biogeochemist Annika Vaxma from NIOZ, the lead author of the study, noted that UV light itself can mechanically break down plastic, but it can also facilitate the breakdown of plastic by marine fungi. After isolating the fungus, the research team took it to the laboratory, where it was grown on special plastics. Analyses have shown that a laboratory fungus can degrade a piece of plastic exposed to UV light at a rate of about 0.05% daily. At this rate of decomposition, the fungus won't do much, but when combined with other microbes and methods it can be useful. Our measurements also showed that the fungus does not specifically use the carbon from PE during its decomposition. Most of the PE that Pharyngiodontium album uses is converted into carbon dioxide, which the fungus expels, Vaxma admitted. Although CO2 is a greenhouse gas, as the study authors point out, emissions from fungi should not be a problem and can be compared to the amount of CO2 that humans release when breathing. The presence of sunlight is necessary for the fungus to use Pe as an energy source. In the Pharyngiodontium lab, the album only broke down Pe when exposed to UV light for at least a short time. This means that under natural conditions, the fungus can only decompose plastic that initially floated close to the surface, Baxma explained. Even if the rate of Pe decomposition was much faster, Pharyngiodontium album would not be able to decompose all polyethylenes, because a large amount of them, and not only polyethylenes, sinks to the bottom and UV light does not reach them. Baxma suggests looking for other fungi that live in deeper parts of the ocean and also have the ability to degrade plastic. Marine fungi are capable of breaking down complex materials consisting of carbon. There are many species of marine fungi, so it is likely that in addition to the 4 species identified so far that degrade plastics, there are other species with similar abilities, Baxma said.